Hello, my name is Poeschko. My talk is called Cloud Notebooks, where I'll give a general introduction to how notebooks work in the Wolfram Cloud, talk about some new and upcoming features, and share some insights what to keep in mind when deploying content to the Wolfram Cloud. I'm the lead developer on the Cloud Notebooks team, and our mission is to make notebook interfaces work on the web and especially in the Wolfram Cloud. Most of you are probably familiar with Mathematica notebooks, but just to give you a brief introduction. Is this big enough or should I? Okay. Give you a quick introduction. The idea of notebooks is, of course, to have computable documents where you can mix regular text, like this section cell here, with math and code and interactive content. So, I can do things like typing a new text cell here, and I can do evaluations, like entering a new computation, and I get back a result after pressing Shift-Enter. Of course, there are things like more sophisticated math that might produce some more complex output, like this one. There is 2D graphics, like this plot. Also 3D graphics that are sort of interactive. When I drag this with my mouse, I can rotate this. I can also resize graphics, of course, and things like that. The sort of interactive part is that you can even create new interactive user interfaces in notebooks. In a simple case like this, you just create a button, and when you click it, let's see, it's a bit slow. Yeah. It produces a new cell in the notebook that just printed something. It's a very simple case. A very powerful function in Mathematica and the Wolfram language is manipulate, where you have some expression like this plot here that depends on parameters like A and B here, and it just magically produces this user interface where you can drag sliders to change the parameters, and the content will update accordingly. So that's how notebooks work in general, and this is what we make work in web browsers, which, by the way, I'm running here, so this is not Desktop Mathematica now. This is my web browser connected to the Wolfram Cloud, and I just happen to have a notebook here that's in slideshow mode. That's why it looks a bit different. So there's, just to emphasize this, it doesn't rely on any local installation of Mathematica or any plugin. It's just the browser rendering stuff on the client side. And then for evaluations, when it needs the kernel, it makes requests to the server, where in our Wolfram Cloud, there are Wolfram engines running to make such computations. So that's the general goal, to make these notebook interfaces work there. Most of the stuff that I showed you here isn't really new. I think that was already working about a year ago. What we've been really focusing on over the last year is sort of improvements under the hood and optimizations mostly. So we've made various performance optimizations in our JavaScript code that renders notebooks. So one metric I had was that I think if you have a large notebook, the initial rendering got about twice as fast over the last year. We've made improvements particularly to graphics, so that especially updates of graphics are faster. Let's say when you have a manipulate and you drag a slider and it changes some parts of a plot, while most of the other things stay the same. That's much faster now, thanks to our use of React, JavaScript library that takes care of updating the browser content. And apart from performance, we also focused on the download size of the JavaScript and also CSS bundles that are needed to render notebooks in the browser. So we've made some progress on that already, but it's still still an ongoing process of optimizing that even further. Not so much reducing the overall size of our code, because that will probably always grow as we add more features, but we try to be more clever about what we really need to load initially to give you to render the notebook initially, and then as you need more of the code, we load that lazily using Webpack and then code splitting. And that already leads into one really useful improvement that we made over the last year, I think, is that we can now really render notebooks on the server side quite well. And the idea is that we produce some static piece of HTML that doesn't really rely on JavaScript anymore, and we can send that to the browser right away when you request a notebook page, so that you see something immediately, or almost immediately, while we download all the necessary JavaScript code in the background. And that eventually makes the notebook interactive, but at least to see something, you get there much quicker. So it feels more like a regular web page in the end, in terms of speed. The way this works is that whenever you edit a notebook and then also close it in the cloud, we generate this static piece of HTML, and also when you upload a notebook, either through the upload button in the cloud or through functions like cloud deploy from Desktop Mathematica. Whenever something like that happens, we generate a static HTML cache for the notebook, and then use it anytime the notebook is visited. It doesn't happen synchronously, and it takes a little bit. So if you deploy a notebook and then visit it right away, the cache might not be there yet. But if you wait a few seconds, any subsequent visit should perform much better. The way we're doing this now has changed over time. We've been relying on browser rendering in the very beginning, where we would send the HTML cache from the browser that was actually editing the notebook to the server. Then we switched to Selenium running on the server, but that had its problem as well. So now we're using a Node.js process running in a headless way on the server to render notebooks, using the same JavaScript code that we also use in the browser. And that works quite well now, I think. It's not only good for the performance of notebooks, but also for search engines, because now that there's some static piece of HTML right on the page, they can make much better sense of the content of notebooks. And so, it's good for search engines. Lastly, what we're really trying to do here is minimize any differences between the static HTML that we render on the server and what you might get eventually in the client side when we render things in a live way in the browser. And one important thing to do to make that happen was to use the exactly same fonts on the server and on the client. Because that static piece of HTML relies on text measurements to know where things should go in a complicated formula or so. So it's really important to have the same fonts, and if it used fonts that you only had on your machine, but we don't have them on the server, there would be differences. And what we're doing now is basically only using web fonts in Cloud Notebooks. So that might be a little surprising. If you take a closer look, you might notice that even if you say a cell uses the font Arial or something, it's not actually using Arial, but just an open font that looks very similar. So you might notice little differences, but I think it still works very well. And the motivation is, or at least part of the motivation is that we have this very good consistency between client and server-side rendering. So that's that. I only wanted to show some new features that we developed recently. This one is not released on the public cloud yet, so I'm going to switch to our test server where this is already running. This should be released in what we call version 144, so probably in the next week or soon after that. So this is a feature called multi-click selection. It seems maybe on the surface like a small feature, but if you're working with somewhat larger expressions in your notebooks, it's really very useful. And once you get used to it, it's hard not having it anymore. So we really wanted to implement this. The idea is that you can of course double-click a symbol and it will select the whole symbol. But then you can keep going and click, make a triple click, just clicking very fast in succession. Oh, there's actually a small bug here. It's weird. And what it does then is it extends the selection in a way where it's aware of the structure. So instead of selecting the whole paragraph at once, which is what usual text editors would do, it just looks at the outer expression and keeps extending it that way. So if I triple click, I get that whole thing, and then if I keep going, it will, have to be fast enough. It will select something like this. So especially if you have large nested expressions, this is really useful to figure out where they start and end, basically. That being said, there's still some work to do. So one thing that doesn't work quite well yet is if you have explicit new lines in your expressions. That's something we still need to fix. And also, it's not necessarily aware of all the operator precedences. So in Desktop Mathematica, if you have, let's see, something like this, it would be aware that the times operator, it binds stronger than the plus, and the multi-click selection would take that into account. Here it doesn't work that perfectly yet, so if I triple click this, it selects only this part when it should really select the first part as well. So that's a minor thing we still need to improve as well. But at least in terms of function calls and arguments, it's aware of that structure. Another sort of user assist feature is spell checking, also coming in 144. So if it's not enabled by default for you, you can go to your user preferences and activate spell checking. And then what you should see is in this case, where it's not really English text anyway, it makes a lot of red underlines indicating misspelled words. You get suggestions how to correct them, or you could also ignore individual instances of misspellings. Again, something that we still need to do is have user-defined dictionaries so that you can add words to a dictionary and then that's never flagged as misspelled. That's something we still need to implement. And of course, it would be nice to share dictionaries between your cloud account and Desktop Mathematica as well. Okay, that's some of the new features coming soon. And these features are mostly related to editing notebooks in the cloud. And so in that sense, cloud notebooks are the primary interface to what's going on in your cloud account, and you can use them to deploy other things like API functions and so on, if you don't have Desktop Mathematica especially. But cloud notebooks are also the underlying technology for notebooks deployed to the cloud that you then can share with other users, even if you don't edit them there. And so the question is, how do you get your content into the cloud? The most straightforward way is to just use Cloud Deploy. So if I have some content like this manipulate here, I can just call Cloud Deploy, and it will put that into the cloud. In its one argument form, it will just produce an unnamed object. But most of the time, if you want to share things with other users, you probably want a nicer URL. And then the second argument is useful, where you can specify the path where it should go to in your cloud account. And also, if you want to share things, you probably want to set permissions. There's a very powerful and complex structure of possible permissions. In this case, we're basically saying that everyone, even unauthenticated users, should be able to both read the notebook and also interact with it. And once we do that, we get back a cloud object, and you can open this link, and it will show me this manipulate, of course, where I can now interact with it, and it just works as expected. I wanted to point out one thing, that Cloud Deploy tries to be somewhat smart about what object it produces. And you can tell if you know things like API function and form function. Of course, it does something different depending on what expression you give it. And it also does that to some extent with sort of notebook content. In this case, it produced an interactive notebook. But if you have a very static piece of content like a grid, and you deploy this one, what it produces is still a cloud object, of course, but it looks quite different. A little bigger. Oops. That was too big. So you can see that it looks very different from what we had here in the notebook. And the reason is that it didn't actually produce a notebook. So there's a little caveat here. If you look at the type of this static object, we can see that it's actually not a notebook, but it's this thing called cloudcdf.html, which really means that it produced a static piece of HTML instead of just a notebook. And sometimes that's probably useful because if you have some simple content, you might not want all the overhead that comes with interactive notebooks necessarily. But if you absolutely want a notebook, there's still a way to do that. And by the way, that HTML that it produced, that's equivalent to what you get by the HTML fragment export format. So what it produced is basically this simple HTML table, and that it put that into a cloud object. But again, if you want an actual notebook, there is a way to do that. You just need to be a bit more explicit. So instead of using Cloud Deploy, you can use Cloud Export, where you can specify the format that should be produced. And in this case, we say we want a notebook, and then again, we just say where the cloud object should be generated. So if I do this, we get a cloud object, and this is now a notebook that looks much more similar to what we had, in our notebook in the first place. Right, so that's a little thing to keep in mind when working with Cloud Deploy. Also something that's maybe not explained very well in our documentation yet, but it's certainly good to be aware of, is the concept of views in the cloud. We make a pretty fundamental distinction between what we call the editor or product view and the deployed view. So the editor view, as the name suggests, is the view where you edit your content in the cloud usually. So if you go to a product like the developer platform or Mathematica Online or also Wolfram 1, what you see is this editor view where usually you have a session kernel that's tied to your browser session, which means that it's actually shared between multiple notebooks. If you have several cloud notebooks at the same time, if you have them open at the same time in the same browser, in the developer platform, for instance, they actually share a single kernel. And if you create a symbol in one notebook, that symbol will be available in the other notebook as well, pretty much like it works on desktop Mathematica by default. So that's your session kernel. It does expire after a certain time of inactivity, and then you just have to refresh your session. Since it's tied to products, it does require a product subscription usually for whatever product you're using. which also means that it's requiring authentication. So anytime you want to go to a product view, you have to log in. Doesn't necessarily mean that you have to pay for this, because there's free subscriptions to most of the products, but at least you have to authenticate. And that's in contrast to the deployed view, which is what you get when you go to www.wolframcloud.com, which is also what Cloud Object URLs usually look like, right? So if you go back to the thing we deployed here, the URL that's here refers to the deployed view of that notebook. If we visit that again, where was it? Just close this for a second. So here you can see the URL. I can actually change this on the fly. So I can go to the developer platform product view by just changing this subdomain here. And it's still the same notebook, same cloud object, but now I'm in a different view where I could also edit this notebook, for instance. So that's sometimes useful. Oops. And yeah, so it's just a different view on the same notebook. And in the deployed view, again, it's meant for public consumption. So what you get there is what we call a public kernel. It's the same thing that also API functions use. There's no real concept of sessions, or at least only short-lived sessions. And it also means that whatever evaluations happen there, they consume cloud credits of the owner of the notebook, since it's not using your session kernel that you have anyway, but might have to spin up a lot of kernels. Well, we have to charge you some cloud credits for that. Again, that's made for public consumption, so it does not necessarily require authentication. It still depends on the permissions, of course. So if you have a private cloud object, it will, of course, not be visible in the deployed view either. But what it means is that if you have a public object, like this one here, it's to unauthenticated users, it's only visible in the deployed view, and they can't use the product view, of course. So this is the thing you want to use if you want to share notebooks broadly, or maybe embed them on a website or something like that. Just one little thing to point out in terms of sessions. That's another improvement that we've made recently, which will be released a little later this year. We've made the whole concept of notebook sessions a bit more robust. So what you won't see anymore is this error message that says session timed out due to inactivity, and then you have to refresh the whole page, which was always a bit annoying. So instead what happens is that even if the session terminates on the server after some time, we can just resume it, basically. And you can keep working on the notebook without reloading the whole page. That being said, the kernel session itself, that still expires after a while. So, and you will still get a little notification about that, but it's much less disruptive. So if the kernel session expires, you make another evaluation, it will just spin up a new kernel on the fly. Finally, some even longer-term lookout. What we're starting to work on now is a more powerful box editor for math typesetting and also grids and things like that. On the one hand, and on the other hand, we're starting to work on live collaboration on notebooks, so that if multiple users have write permission on a notebook, they can all edit it at the same time. There's still a lot of questions to be answered about that, but we're making some progress. And especially if you're interested in that, have some use cases for either of these, please let me know. And we're out of time now. So thank you very much.